and welcome to the Absolute Recap Biology Edition, where we aim to maximize your understanding and minimize your need for memorization. Each episode will recap content, skills, and test-taking tips to help you succeed in May. I'm your host, Melanie Kingett, and your recap starts now. Hi, and welcome to the Absolute Recap Biology Edition. Today's episode will recap passive transport. Let's zoom out. We're in Unit 2, Cell Structure and Function, topics 2.5 to 2.9. Our big idea is energetics.
Warning, the following is a fart-related scenario and is probably based on true events that would eventually result in the widely publicized trial of the people who smelt it versus those who may or may not have dealt it, and is therefore not a laughing matter because farts are serious and not funny. Ooh. Oh no, not on an elevator. Oh man. Well, at least no one was in here when... Okay. Just act natural. Play it cool. It probably isn't that bad, and they're not gonna notice. Ooh, it's bad. And they're definitely starting to notice. Quick, accuse someone else before they think it was you. You. Which one of you barn animals farted because it reeks? Nailed it.
Whoever smelt it, dealt it. A common phrase when trying to pin the passing of gas on an unassuming friend. But there may be some truth to it. After all, molecules move from high to low concentration. So, the most likely person to smell the odorant initially is the one who produced it, with greatest concentration. Bringing biology, physics, and chemistry all together to answer this age-old question. Why did the fart cross the room? Time to concentrate. Let's zoom in. Starting off, as we often do, with a nerdy word moment. The prefix trans comes from the Latin meaning across. And port, just like the location for ships to dock in the harbor, also from Latin, porto portare, meaning to carry. So transport, to carry across. And so, passive transport is the method of moving solutes across a membrane without the use of cellular energy. Let's take a moment to remind ourselves about the structure of cellular membranes, as this will be the barrier that must be overcome for anything attempting to cross. We refer to the plasma membrane as a fluid mosaic model. It is composed of a bilayer of amphipathic phospholipids with embedded proteins, cholesterol, and carbohydrate chains, some continuously shifting around the surface of the cell membrane. It is very dynamic, and because each of the plasma membrane components has unique chemistry, specifically hydrophobic or hydrophilic, the molecules that it interacts with for transport will also be distinct. First, we need to remember that molecules are always in motion due to kinetic energy. They bump into each other often, even more often in warmer temperatures, or in areas where they are crowded, also known as concentrated. Passive transport is the net movement of molecules from an area where they are more highly concentrated, like 2 molar, to an area where they are less concentrated, as in 1 molar, without the input of metabolic energy or ATP. We say net movement because molecules don't have an agenda, and even though it is more likely that molecules will bump into each other and spread out, a few will also bounce over to the more concentrated area. Passive transport has a direct role in the import of materials and the export of wastes. To get across the plasma membrane without the use of energy, there are 2 options. Sneak in between the phospholipids themselves, or use a transport protein. Small, non-polar molecules like oxygen and carbon dioxide can pass freely directly through the phospholipid membrane, since the fatty acid tails are also nonpolar. This movement of molecules from high to low through a membrane is called simple diffusion and is a type of passive transport. The diffusion of oxygen and carbon dioxide across membranes is crucial to the process of cellular respiration and external respiration from your bloodstream to the alveoli of your lungs.
Hi there, Producer Brad here. You may be saying, what the heck is going on here? To that I'd say, this is a recording and I can't hear you. Now, I'm not usually given the chance to speak on the podcast because I'm not a teacher, in the literal or figurative sense. I was at one point a student and a poor one. Therefore, I consider myself a bit of a connoisseur de tutor, which is Latin for tutor expert. So I know quality tautology when I see it, and the Absolute Recap virtual tutoring program is top-notch. AP classes are challenging, and sometimes you may need extra help. If you are looking for more in-depth, personalized support, sign up for virtual tutoring with your favorite podcasting teacher. Each 60-minute session is held through Zoom and is structured to meet your specific needs. So if you have a big test coming up, just can't master those multiple choice questions, or need help improving your writing skills, we've got you covered. Our tutors provide opportunities for you to practice content and skills with graded feedback. Visit our website to reserve a session with a tutor for your specific subject and time zone. Now back to the recap.
Small polar molecules, like water, can also pass through, but in smaller amounts. Osmosis is the term for the passive diffusion of water. Same rules apply, however. Water will flow from high to low, down its concentration gradient without the input of ATP. Areas that have a greater concentration of solutes, such as ions, sugars, etc., are hypertonic compared to areas with lesser solutes. The prefixes hyper and hypo refer to the relative amount of dissolved solutes in a solution. Since hypertonic solutions have more solutes, they have a lesser water concentration. Assuming that two solutions are separated by a semipermeable membrane, water will flow from a hypotonic area to a hypertonic area until the water concentrations are equal, or isotonic. Water is still moving between the isotonic areas, but at an equal rate and in both directions. Be careful.
Wait a minute. We have to be careful.
Equal concentrations does not mean equal amounts. This means that water will enter or exit an area, or cell, whether there is room for the water volume or not. Vacuoles, both contractile and storage, are cellular organelles which contribute to osmoregulation. You'll need to dive deeper into water potential for the full picture on osmosis. So we've covered movement through the phospholipids. Now let's talk about movement through a membrane protein. The movement of molecules from high to low concentration through a transport protein embedded in the membrane is called facilitated diffusion, or literally diffusion made fácil, the Spanish term for easy. Anything large or charged needs the use of a transport protein, either carrier or channel. Since proteins are composed of amino acids with distinct R groups and folding patterns, it is safe to assume that these transport proteins will be chemically picky about the types of molecules that use them. Carrier proteins are integral glycoproteins that bind with specific solutes and undergo a physical conformational change to move the molecule across the membrane. This interaction is similar in nature to an enzyme-substrate interaction. In contrast, channel proteins are lipoproteins that have a pore, which is sometimes gated, allowing specific ions to cross. Membranes may become polarized from the movement of ions. When water moves in larger quantities, it passes through a channel protein known as aquaporin. Channel proteins have a much greater rate of transport than carrier proteins. Time for unit connections. You'll find passive transport concepts in Unit 3 with cellular respiration and photosynthesis, and Unit 8 with energy. After all, the mechanisms of transport support energy conservation. All right, what about the exam? You may be asked to make transport predictions based upon membrane models, apply graphical representation to transport rate, analyze experimental results, or contractile vacuole rates. Follow the concentration gradient, and you can apply it to any unknown situation. To recap, passive transport is the net movement of molecules from high to low concentration without ATP. It's true. Whoever smelt it most likely dealt it, as solutes diffuse from high to low concentration. Small, uncharged, nonpolar molecules diffuse directly through the membrane, while large or charged move through a carrier or channel protein. Coming up next on the Absolute Recap Biology Edition, active transport. Today's question of the day is about tenosity. Describe the cellular condition of a red blood cell placed in a hypertonic solution. For the answer to the question of the day, please follow us on Instagram at TheApsoluteRecap. That's the APsolute recap. Check out our website, TheApsoluteRecap.com, for episode schedules, study guides, virtual tutoring, and to sign up for our virtual classroom. The Absolute Recap is produced by Brad Kingett with music by Zach Caruso. Today's episode was written by me, Melanie Kingett. Thanks for subscribing, and don't forget to rate and review wherever you get podcasts. Time's up, pencils down. Thank you for listening to the Absolute Recap Biology Edition. AP is a registered trademark of the College Board. Copyright 2020, Absolute Recap LLC, all rights reserved.